On today's episode of the Ag Irrigation Collective, we're going to be discussing water delivery. Stick around. Hi, I'm Wes Schaefer, your host with the Ag Irrigation Collective. We appreciate you stopping by and joining us today on the podcast. One thing we're going to talk about as we creep into the new year of 2025 here, this is the first podcast in 2025 coming from the Ag Irrigation Collective, is water delivery and kind of what that looks like, and go through some of the different methods and ways that we get water out to the irrigation fields. So settle in with us here and we'll go through some of this stuff. There's several different methods that water makes it to our fields, and those methods started out basically with one method, and well before there was any pipe and any of that stuff, we were into basically reservoirs. And those reservoirs then would go into canals and be basically flood irrigation is all we would see until we got into some more pumping stuff. So we're going to discuss some of that here. So with reservoir water holding, that can look differently under different circumstances. So water can come from several sources that it's held in a reservoir. One of those is water can be pumped into a reservoir from either groundwater or river water, and so you can fill a reservoir that way. Reservoirs can also be filled through water runoff that is coming off of, say, spring melt from snow off of mountains. Can also come from other types of runoff. There can be runoff from other higher elevation type of areas of fields or things that runs into lower reservoirs. We see stuff like that. Damming is also a method to create a reservoir that you basically build a dam across a river, and it causes that river to rise, and it forms an artificial lake. And you see that like Hoover Dam down near Vegas creates an artificial lake, basically. You can also have damming of a natural lake, and the reservoir is then formed when you dam the outlet of a natural lake to control that water level. So the water level may have been at a certain point, and you go in and dam it up, creating that water to rise, and you control when it is released. So there's that form and method of water holding and water collection. And then once we release water out of those reservoirs, there's several different ways that it can leave those reservoirs. One of them is either an open canal or a ditch. And canals are gravity flow for the most part. They flow from the reservoirs. And if you look at any of these water systems that were basically dug way back, late 1800s, early 1900s, with team of horses or team of mules and basically a dredge that they're pulling and digging these canals, the old timers that were digging those, very few of them were engineers, but all of them were engineers. It was interesting because they had to make the pitches and slopes just right to be able to get that water to flow the direction they wanted it to. And to be able to put systems like that in place is absolutely mind-blowing to me. They did it, of course, without any computers, any type of calculation. As far as computerized calculation, I'm sure they did plenty of their own calculations, but they were very smart, and they had to come up with that on their own. So canals typically will flow out of a reservoir and head down a system. And then from that system, those canals typically feed smaller ditches or smaller canals that head toward the farm fields. And as they head out there and under flood scenarios, you pull that water out of those ditches and can flood across your fields as you need to. And there's quite intricate systems set up, and water companies that, people are on water turns, or you call for how much water you want. And there's all sorts of metering devices, partial flumes that they measure open ditch flow with, and different things like that. So it's pretty interesting, that old technology, if you'd call it that. So your ditches then deliver your water to the farm fields. And all that was in the olden days, we'll call it, in the early 1900s, was flood irrigation. Very effective method, used an awful lot of water, but it was extremely effective. It was high labor, and it still today is high labor, as we have floods still being used in a lot of areas. Then we get into the next stage, which is piped irrigation water out of your reservoirs. So there's a couple of different ways that they do that. It can be directly fed into a pipe from the reservoir or the pond or the lake or whatever you want to call the reservoir. Some ponds or reservoirs are high enough elevation up on a mountainside that it eliminates the need for pumping. For every 10 feet of elevation change, you get a 4.33 psi change in pressure, whether it be up or down. So if your pond, for example, the level of your pond is 100 feet above where you will be utilizing this water, you now have 43.3 pounds of pressure from that 100 feet of elevation change. Same story, if you have to get water up 100 feet, you need to give it 43.3 psi just to get the water 100 feet up to overcome that elevation change. So if the pond's high enough, you can pipe it. There's no pumping necessary. In the region where I'm at, you get from all up and down Utah, there are several places where it's even possible that we need pressure reducing stations because of the water that's coming so high from up on the mountain that we actually need to bring the pressure down. So sometimes pipe is fed from the canals, so we have it coming from reservoirs, but also that reservoir may feed a canal, and then we may choose to take that water down the line a ways into some pipe. And usually at that point, you do need a pump to boost your pressure when you're pulling out of a canal, depending upon if you're going into a pivot or a wheel line or a hand line, or let's say like a traveling big gun cart or a water reel. You typically do need to pump that water to gain back up your pressure that's desired for whatever method you're sprinkling with. However, you also may flow into pipes down and irrigate out of pipes, which is called gated pipe, and typically they're on 30-inch spacings, and those gated pipes then gravity flood. And so you can have a pipe system that then goes into flood irrigation that no pumping is necessary for that flood irrigation. So it really depends on your final method, whether you're flood or sprinkling, if you do need that pumped water or not. But when you do pump it in pipes, you now can utilize sprinkler irrigation, by putting that canal water into a pipe, basically creating a pressurized water system. So once it comes from the canal, whether it's into some type of sump box or into a smaller pond and then feeds into your water system, a lot of guys will put it into a smaller pond right off the canal for some settling purposes to kind of clean that water up, act as somewhat of a natural filter, if you'd call it that, and then they flow into their piping system, thereby turning it into a pressurized system. And there are sometimes when you do need a pump to pressurize that system, depending on your elevation, you could choose to put the pump at the canal, or you could also choose to put the pump more like, say, at the pivot point if it's a lower elevation than at the canal, thereby having what's called a flooded suction to that pump. So there's a lot of different ways to design some of those pressurized systems. It's pretty neat to be involved with that. So as we move into pressurized irrigation systems, now we get into pumping your irrigation water from a reservoir, which is another method as opposed to just piping it out of that reservoir. So when you pump out of a reservoir, it can be pumped by several methods. Usually it's pumped directly into a pipe. However, it can also be pumped out of the reservoir into a ditch. That's quite uncommon, but I have seen it, that they're basically pumping, and it depends if that ditch or canal is higher than the reservoir and you pump it up to it, and then it can have a downward flow on gravity. There are certain scenarios where that is a possibility. One other type of pump to utilize out of a reservoir is called a short set turbine pump. And a short set turbine basically sits on a vault. It can be outside of the pond bank. It can also be inside of the pond bank, and you can have a catwalk that goes out to it. That pump essentially the motor is a vertical motor, looks just like a deep well pump, but it's right at the edge of your pond. And that's the purpose for calling it a short set, is it only goes down, let's call it 10 or 12 feet with your bowls into that water. It pumps it out, no priming necessary, and it'll pump it right out into your system. It is possible you'll need to boost that pressure once it gets out to, say, you're pumping to 6 different pivots. That pump may get the water to your pivots, and you need to boost it again to get it into your pivots to get your desired pressure. So there's a few things there that can be changed. You may or may not need a booster pump midway or at the pivot point, depending on what you're doing. Another one is a submersible pump that you can utilize pulling water out of a reservoir. I think those are less common. I've seen fewer of those than, say, a short set turbine. They are in existence, is why I wanted to bring them up in the podcast here. But a submersible pump is exactly what it sounds like. The entire pump and motor are completely underwater, and they basically pump that water up a column, and then it goes out into your system. There's some very large submersible pumps. There's a 50 horse just over here by where I'm at that's a submersible, and I think he's pulling from 250 or 300 feet with that submersible. He's really, really down there. So, and then another one out of a pond, these ones would be on the outside of the bank of the pond, is a surface centrifugal pump. And there's a couple of different types of surface centrifugal, and it probably is true for all types of pumps this way. There's either a high pressure, low flow, or a low pressure, high flow. So one thing you can think of with a low pressure, high flow, if you think of like a trash pump with say a Honda engine on it, those are a low pressure, high flow. They are designed to move a lot of water, but not very much pressure. And it goes in inverse to that is when you have higher pressure, it's a lower flow. So it doesn't necessarily mean that you can only do 2 or 4 or 6 gallons a minute. It just means that you're not going to be doing 4,000 gallons a minute at 100 PSI. There's the affinity law. When one thing goes up, the other goes down, inverse to that, and same story. You go up and down like that. So the affinity law goes into the pumps or the affinity principle. I don't remember if it's a law or a principle. Maybe it's both. I don't know. But anyway, so you work into knowing on what pump you need. And on a surface centrifugal, it is not submerged. And the impeller portion also is not submerged in the actual body of water. It flows through the bank of the pond out to the pump, and then you can send that water that direction. There's also another one, and this one I think is primarily used to pump into canals and not necessarily into pressure systems, is a propeller pump. And a propeller pump is basically that. It has a prop on it, and it is designed for that low pressure, high flow, and it moves a bunch of water. I've seen those propeller pumps used in slurry ponds, at dairies, pig outfits, different things like that. They use those propeller pumps to move a lot of that slurry really fast. So another method of water delivery and where the water's coming from is pumped water from underground aquifers. So there's a lot of places, and it's interesting. In the state of Utah where I'm at, there's one valley between the mountains that is primarily a canal system. And then you jump over the other mountain, and it is all underground aquifer pumped water. It's interesting, and they're only 60 miles apart between mountains here, and there is zero canal system over on that other side of the mountain, and this side of the mountain you run into this where it's a whole system like that. It's just an interesting dynamic, and I know throughout the Midwest and stuff, there's a bunch of pumped water. And there is also flood in the Midwest. But anyway, with with the water pulling from a underground aquifer, we then accomplish that by a couple of methods, probably not as many methods as these other. One is a submersible pump. You can drop a pump down a column and have your whole motor and pump submersed in the water, and it pumps out water up the column, and you send it out. For a lot of home applications and smaller applications, that's what you see as a submersible pump. And then for your larger high volume, high pressure systems is a centrifugal pump that uses a set of bowls that's a deep set hollow shaft turbine type of a setup that is a vertical electric motor. Typically, I've seen, of course, diesel powered and other petroleum powered pumps and things. And so that does exist, but most commonly, I believe it's an electric motor that's a vertical motor on top of those, and it heads, it'll pump just a ton of water. When you're pumping from underground, you're usually into a piped pressurized system. It's very uncommon, I think, to pump into a reservoir out of the ground. It does happen, but the most common is to pump right into a pressurized system. And sometimes your pump that pulls it out of the aquifer is just enough to get it out of the ground, and then you do need another booster to send water on down the way. And depending on the region and the aquifer, your pumping depths vary quite greatly. And so really these well driller type of outfits, they'll come in and they'll be able to get you tuned in just right. There's some areas where I've worked on that some of those wells have been 800 feet deep. Then you go 200 miles to the north and those wells are 180 feet deep. And so it's just varies wildly and crazy what it is. And so anyway, that is some methods of some water delivery. We are in a future podcast going to get into dive deeper into types and styles of pumps and also the control panels that go with those, which would be, I'll cover what they are right now, is a cross-the-line panel, starter pump, motor or starter pump panel, soft starter pump panel, as well as a VFD, which is a variable frequency pump panel. And so there's a lot to dive in with pumps. We're going to get into those in a future episode, but I thought it'd be kind of interesting to visit with you about kind of some water delivery methods and the different forms of water delivery that we see in agriculture and where we're getting our water from. It's sure interesting. So sure appreciate you stopping by today. Go ahead and comment on the post here if you have anything that you feel like I need to add in a future episode. Subscribe to the channel here. Go ahead and follow the podcast if that's where you're listening to this. Share this around to your friends. We sure appreciate you joining in with us today. And I know I'm better for it. Appreciate you stopping by. Be profitable, my friends. We'll catch you on down the road.